My name is Kayla Katz, and my project is the Fibre Lab Collective. This research asks, what can we do about increasing waste streams when 55% of the world's population currently resides in condensed urban areas? This question will be explored alongside a personal dilemma that came from being a conscious designer and wondering if fashion could ever be truly sustainable. My journey into the industry started in 2016 when I completed my BFA in fashion design and later moved to New York City, where I worked as a freelance designer and stylist. I later went on to work for a large, fast fashion brand where I saw firsthand the unsustainable realities of the global fashion industry. This is where I knew I wanted to be part of the solution instead of continuing to contribute to the problem. Which has brought me to where I am today, completing my final year on the MA Fashion Futures course at London College of Fashion. My Fibre Lab research is focused on developing resilience and regeneration within urban hyperlocalized settings and exploring the materials and systems needed to create an urban fibre shed. This research will take place within the borough of Waltham Forest, London. The fibre shed is a regenerative fashion system that takes place in a rural setting and encompasses the entire fashion supply chain, from raw materials to garments, all within a 150-mile radius. The system utilizes material sources that are native to the rural landscape, such as wool, cotton, and bast fiber. However, these processes are distinctly suitable for those of a specific rural demographic with access to and ownership of land. My research asks, how can urban landscapes with limited space and expensive real estate develop their own regional textile or fashion supply chains? And what materials could be used to fuel the development of regenerative fashion systems within an urban setting? In order to answer these research questions, I've decided to focus primarily on the borough of Waltham Forest, London. This borough has a robust industry of fashion manufacturers, designers, makers, and artisans. The first step of the research methodology was to do a site analysis and mapping of the existing fashion ecosystem in the area. The following diagram breaks down the elements of the fibre shed system into three main categories, consisting of fashion production, community networks, and end-of-life phases. In order to build off this research, I've mapped the end-of-life phases, such as repair and care, which consists of dry cleaners and tailors, resale and reuse, which consists of charity shops and vintage stores, and recycling centers and textile recycling banks. These recycling centers act as collection points and sorting facilities, but are not capable to recycle materials on site. This is where the Fibre Lab project steps in to close the gap in local infrastructure by setting up an educational material testing and recycling studio. The studio is funded by a grant from Procter & Gamble's Better Lives Award and is located in the local fashion hub at Artbyte Studios. This space was granted from the local council as a trial for the next 8 weeks. Prior to setting up the studio, interviews were done with the resident designers at Artbyte, as well as the wider fashion business community in order to identify their waste streams and co-develop circular solutions. Textile and plastic waste are among the most concerning and prevalent in the local industry and can be separated into three main processes. The technological cycle consists of plastic waste and synthetic fibers, which can then be melted down and used as a raw material source. The biological cycle includes cellulose fibers and food waste that can then be composted locally or recycled into new materials. And lastly, blended textiles, which require new technologies such as chemical recycling to separate the fibers and feed them back into their separate cycles. Waste samples were then collected from participating designers and sorted by fabric quality and then by color. A sample of cotton fabric was then put through the custom-built small-scale shredding machine to achieve the medium-sized pieces. After attaching a 6mm mesh to the shredder and putting the sample through again, a much finer, pulp-like fiber was achieved. This final sample is comparable to industrial-scale quality. The cellulose pulp can then be combined with a bioplastic or bioresin to create a firm, long-lasting material that could be used in a variety of applications, from furniture to fashion artifacts and accessories. Alternatively, the material can be combined with regenerative cellulose to be spun into new fiber, or simply can be composted to fuel local food, fiber, or dye cultivation. A similar process of shredding, melting, and molding will be followed with plastics and synthetic fibers to create a filament that can be used to 3D print fashion artifacts. My last challenge remains in small-scale chemical recycling, as this knowledge is currently protected by patents and is less easily accessible. Overall, this research acts as a proof of concept that communities can implement circular solutions by intercepting local waste streams and using them as valuable material resources. The knowledge generated and machinery used will be open-sourced and documented in a Fibre Lab framework that can easily be replicated in other cities all around the world. This low-budget setup also offers developing nations a solution to dealing with the mass amounts of waste that have been sent there. In conclusion, the project builds off the FibreShed system that uses regionalized supply chains and local resources. In the urban context, this is waste, not wool.